the radius for XY plane, or the maximum shear stress in the XY plane. Okay. So now we have to determine what is stress C. Okay. So stress average in the XY plane is straightforward. It's equal to stress X plus by stress Y, and we need to divide by 2. Right? So you that is your stress average for your XY plane. And then the next thing we have to find is the radius, right, for the XY plane. And this is equal to tau max for the XY plane. Okay, so this will be equal to, over here, this will be equal to stress X plus by stress Y divided by 2, the whole thing squared, right? And then we have to include plus our shear in the XY direction squared. So finally, we come up with a form that we have our stress max will be equal to our stress max will be equal to stress X plus by stress Y. So our stress max is equal to stress X, right? Because now we know the radius, right? We also know this distance over here. So it's equal to stress X plus by stress Y divided by 2. And then we have to add the square root of stress X plus by stress Y over 2 squared plus by shear XY squared. Okay. And now don't memorize all this, okay? Just everything derived from Mohs circle. And then finally, we know that the tau max is equal to stress max divided by 2. Okay, so you just put the whole thing. Okay, you just take the whole thing and just do this. And you just close the bracket. Okay. So this condition, right, this condition over here, right, is true when stress X, okay, so this is valid, like what I said before, when stress X is greater than stress Y, both are positive. And stress Z is equal to 0, and shear XY, which is equal to shear YX, is not equal to what? 0. Okay, then this is true. Okay. Now, if both are negative, okay, if stress X and stress Y are negative, right? I will start on another page. Okay. If stress X, I'll copy this image again. So what will happen if now the condition change? Okay, and I will not drop off, but rather I will do this. What if now it becomes compression? Okay, if when so the condition when stress X and stress Y are both compressive or compression. So what will happen is this. Okay, so I'm going to not draw, but if I could save some of your time, we just take this right? If I could. I don't know what will happen. Okay, I'm going to try. This is my first time doing this. I'm going to paste. And I don't know. Hopefully the words will not be flipped. Okay. Rotate. Oh, the words are flipped. Okay, it's okay. It's okay. So if it's flipped, right? Unfortunately, they did flip. The words did flip, unfortunately. It's okay. Right? So when it is it gone the other way, I will just write them in words that you could comprehend. Okay. So if it's flipped over or if it's in compression, right? Yeah, I need to get rid of all this. Okay. I just need to label them. Okay. So what we have, right? So if it's in compression and the compressive stress for point X is smaller or more compressive than Y. So this is our stress X in compression, stress Y. This is your shear element rotate clockwise, anti-clockwise. I need to change this arrow and I just need to draw it in the other direction. Right. So this is the normal stress. And then if I see point X is rotating in the anti-clockwise, yeah, point X will still not change. So this is still our point X, right? Compression, anti-clockwise, clockwise compression. This is still our point Y, right? It's still the same. Okay, so this is still our stress average. Okay, and this is still our tau max. Okay, so the formula still work. Okay, so if we were to the formula, so this is still valid, right? To calculate tau max. Now you just have to remember stress X and stress Y are both negative. Okay, so this expression, okay, this expression over here is still valid. Okay. So if your mole circle, so what I'm trying to highlight, so what you see over here, okay, in summary, okay, when stress X and stress Y are in either compression both compression and both tension, not and or, sorry, or both tensile, right? Right? With stress that is equal to 0, then what will happen is tau max is equal to stress max or, okay, stress mean divided by 2. Right? Because over here, yeah, the only thing that is different is this point is equal to our stress mean. Okay, I have to change this. This will be equal to our stress mean divided by 2. Okay, as you can see from here. Okay, so this is one condition. Now, in Tresca, you can also see another form. Okay, So Tresca condition, right, also states, okay, so what do you say? What do they state? It also states where how max, so the other condition, okay, the other condition is where tau max is equal to the absolute value or half of the absolute value of stress max minus by stress mean divided by 2. Okay, so this is our equation number, I think this is should be equation number 3. Then let me, yeah, our equation number 3. Okay, so we will ask ourselves, hey, when is this condition true, right? When is this condition true? So I can highlight one condition where this is true. Okay, again, we come back to 3D Mohs circle. Oh, I'm going to construct an element first. So on an element now, this is our x, y, and this is our z. So for this case, we are going to have an element now, right? Where this is in stress x, okay, sorry, in 3D. And then we have a shearing stress. Okay. So for this case, our stress y and stress z is equal to 0. Okay. Stress x is positive in tensile, and shear xy is equal to shear yx, and this is our positive shear. Okay. Does not matter whether it's positive or negative. So how does the Mohs circle look like, and how will the formula now evolve? And we have to be really careful now. Okay, so if you have a condition like this, okay, so we are going to sketch 3D Mohs circle. The most important thing for this method is you always have to construct 3D Mohs circle, okay, to see which formula to apply. If you were not to construct 3D Mohs circle, that's where the issue comes, okay? So now we're going to construct a 3D Mohs circle. So now we have a zero stress, okay, on so normal stress, and then we have, I'm going to I have to do something with negative now, so I'm going to leave more space for the negative aspect. So now we have our normal stress, shearing stress, element rotate clockwise, element rotate anti-clockwise now, right? And this is our 0. And then we are going to label, right? So this is our x, this is our y, and this is our z. Okay. So for this case, I'm going to have this is our normal stress in the x direction. And we know that stress y and stress z now is on the same line. Okay. And then we are going to have a shear now. Okay, so I'm going to now sketch a shear. And this is our shear line. then we are going to have another shear line over here. Okay.